Yay. So I'm the co-founder and CEO of Navteca. We're a technology company located here in Maryland. We work with a lot of emerging technologies and innovation. A very long time collaborator with NASA. And I'll be telling you about some of the sort of innovation side of things. You actually heard a little bit yesterday about our Open Science Studio in Rachel's presentation and our collaboration with the Open Geospatial Consortium. So I'm going to focus a little bit more on what the future holds when we do have decentralized web and some of these technologies. So some of this is going to be very much on the sort of future vision R&D side. So hopefully it's going to be interesting and spark some ideas. As I mentioned, we're a small company, but small but mighty. We've always sort of been on that kind of bleeding edge of things, ahead of the curve. So hopefully some of the projects that I'll share with you, you'll be able to get a good illustration of that. We do a couple of other types of things. We have a lot of bread and butter work in the cloud computing realm and doing HPC in the cloud. We work with a lot of scientific teams. We were one of the first groups that actually helped scientists at NASA move some of their big algorithms into the cloud, also at NOAA. And then I'm also going to be telling you about our conversational AI product, Voice Atlas. I wear a lot of hats. I call myself the Chief Everything Officer. So I've also been the PI on a couple of different NASA grants, specifically looking at these type of technologies for science, earth science in particular, and then really have narrowed our focus down to looking at disasters. And I'm currently the PI on a grant with the wildfire program through NASA. We also have a couple of projects going with the Open Geospatial Consortium. We've been a long-time ESIP collaborator, so we've definitely tried to be part of that science community and really focus the technology tools that we build on how to accelerate science. The truth is, we have more data than ever. We are inundated with information and data, but it's not necessarily well connected. It's hard to connect the dots. Even sometimes within a same organization, you have information that's siloed. So our goal with a lot of these technologies and R&D is to really try to make that data more understandable and therefore more actionable. So let's talk a little bit about finding information, data discoverability, data accessibility. When we have to find that in a traditional sense, we need to know what the keywords are. They need to match the metadata tags. As you're well aware, there's a lot of issues with that. So if I, search in Google, I can get pretty decent information if I ask a question. A lot of the big search providers are moving to more of a conversational approach. And actually over 50% of internet searches are actually initiated via voice. People are talking to their devices and asking questions, rather than using the traditional search mechanism and just entering in keywords. Now, if I go to a NASA data portal, not to pick on NASA, but this is typical of science institutions. If I look for that, first of all, I can't ask a question, but if I just look for that keyword heat wave, there are no results. Well, everybody knows it's actually temperature anomaly across the board. We have examples like that, right? Where the scientific terminology does not match how the end data user will refer to something. We had record rainfall recently in the mid-Atlantic. If I go and look for rainfall, I'm not going to find it. It's tagged as precipitation and on and on. So using a conversational AI approach can help to bridge that gap and make this information more accessible and more discoverable to the people who critically need this information for action. So this really follows industry trends, right? We already know that people are using Alexa devices. They're using Siri and Google. But the issue is that they can't necessarily get to the trusted information. They can't necessarily filter through the misinformation and all of the things that are out there. If you ask Siri a question and get an answer, you don't know the source. You don't know where it's pulling from. But at the same time, people just want an answer. They don't want to go through a whole list of things. They don't want to go through a bunch of links. If you think about your workday, how much of your time is actually spent facilitating information for other people? You don't have to answer, but usually the answer is pretty high. 30%, 40%, 50%, answering questions for people both internally in your organization or maybe externally. So that's where we think that conversational AI comes in for geoscience. because it makes a way to centralize access to lots of information from vetted sources. So again, we're not just going out to the internet or Wikipedia, we are controlling the source of knowledge and pointing a conversational AI system at something that says, yes, this is where I want this information to come from. We can ingest information from lots of different types of sources. So now that opens up, again, that accessibility piece in terms of searching through documents from trusted URLs, even bringing in real-time information via API. On the back end, it also, with our system, gives you a way to be able to see every single question that is being asked and answered, which can provide real insight into what are people looking for? Are they finding it? Is this useful to them? Is there a gap in the knowledge base that we would want to fill? And then from the science perspective, this can also be deployed in Jupyter notebooks. That's a really cool use case that a lot of scientists that we're working with are excited about, because it gives a little chatbot function within the notebook, and now the notebook itself becomes the knowledge base. So you can ask questions, what algorithm are we using, or where's the GitHub repository for this? And it's all pulling directly from that knowledge base. So I'm going to tell you a little bit about some case studies of how we're using these conversational AI deployments for science. So for NASA, we started off with a pilot project for their disaster portal. We're also using it as part of this wildfire research grant. We're working with a couple of projects with the Johns Hopkins University Applied Physics Lab, a couple of things on center and also out to the public. So you've probably heard there's a big eclipse on Monday. We're part of the Parker Solar Probe mission, and this is on their website. I'm actually going to get to be on CNN later today to talk about this. Yeah, so exciting. I still had some little stickers that APL printed up, which I can hand out with links to this, and they renamed it the Parker Bot. So it's a really great way to try out this instance. And I think it might be the first NASA mission actually using conversational AI, to provide information for the public. And it's really allowing their team to do more with less. Tiny communications team. And this is going to really facilitate being able to provide information across a wide geographic area in 135 languages. I'm not going to go too much into the DC government use case, but it's worth mentioning because, as governments are also looking to improve their citizen services and the way they facilitate information, it's worth noting that this is also a public facing project, so you guys can try it out, and I'll share the URL with you. So for Parker Solar Probe, this is a really cool mission. It's a spacecraft that's getting closer to the sun than humans ever have before. And there's a lot of really cool science that's not necessarily accessible to the general public. The word heliophysics isn't even in the dictionary. So, using a conversational AI system can really bridge that gap between the very complex information that's out there around the mission, and then being able to distill it into a format that makes it more understandable. So now you can just ask questions, and the bot meets you where you're at. So if you ask, if you're a little kid and you ask, why doesn't the solar probe burn up when it's close to the sun? It answers you on that level. And if you're the project scientist and asking it questions that are much more complex about the structure of the sun, or what has Parker Solar Probe learned about the solar winds, it's going to answer you on that level. I mentioned it's multilingual. You can ask in your language of choice, and it returns that information to you with no additional translation needed. So all of their knowledge base is in English, but it's returning languages directly in the language that it's approached with. So obviously for, the accessibility component, that's huge to be able to now take your information and make it available to people. This is a QR code that will take you directly to the Johns Hopkins University Applied Physics Lab website, and you can play with the bot. I also have stickers I can pass out later. The more people who try it out, the better. This provides a lot of useful statistics and metrics back, and we're already getting really, really great results around this in terms of seeing the types of questions that are being asked and really giving the team that insight into what do people want to know about the mission and being able to really expand on the knowledge base. So for example, initially there wasn't too much information about the eclipse in here, it was a little bit, and they really broadened that of seeing so many people asking questions about how can I see the eclipse, where do I get eclipse glasses, where's the path of totality. And so what it does is it now provides a lot of links out to some of the NASA tools, interactive maps, and all kinds of resources that are out there. So, you hear that term one-stop shop a lot, and it's very overused, but this type of chatbot truly can be that, because it's almost like that reference librarian where you can ask, where do I go next for the piece of information that I need? How do I do my next step? And this points you on your way, can give you that link of what you need to do next. So for Washington, D.C., similarly, we have a couple of different use cases with them. Some are internal. We're actually building an AI SCIF environment where they can look at highly sensitive documents and use Voice Atlas to interact with that. But then on the public-facing side, the CTO contacted us and he said, we've been trying to build our own chatbot. It's not really working. Can we use Voice Atlas for that? We said, yep, all you have to do is just index the URL. So if you go to dc.gov/AI, you can try this. There might be some DC residents here. You could get some good information about city services. And it's really cool because it is connecting knowledge from across 130 websites, many different agencies. DC is kind of like a city and a county and a state all wrapped into one in terms of the types of services that it must provide to the citizens. So you can imagine the difficulty of just getting an answer to a question if you have to go and search 130 websites. So again, this is a way to synthesize information from across this trusted knowledge base and provide information back to the users. We've done all the prompt engineering on the back end to ensure that the bot is polite, that it's friendly, that it's professional, and also that we have filters in place so that it will not return any content that's inappropriate, racist. It can't be goaded into seeing things the way ChatGPT can. You can't enter a text string and get around the guardrails. So it gives governments and enterprise the confidence to be able to use a system like this safely and not end up on the front page of the Washington Post for having said something crazy. Yeah, the New York Times, yeah. So New York City just unfortunately got a lot of negative press around a similar type of instance. Unfortunately, their chatbot, I guess, didn't have some of these guardrails in place. So I actually took the questions that were asked to that and put them in to Voice Atlas with DC and was able to verify, our bot is definitely saying that it's illegal to sell human meat for consumption. There's all kinds of people out there who want to get you, they want to just see. So luckily we passed that test. So one nice thing too is this is a way to highlight multidisciplinary efforts, because a lot of times information shouldn't just come from one place. It should come from multiple places, and we should be able to really get that synthesized information across multiple sources within that knowledge base. So in this case, we were asking questions about sustainability efforts, and on the back end, you can see that it's pulling from like 10 different websites. So it's giving a much broader overview of what DC is doing for these efforts. Yeah, it doesn't have to just be websites. You can upload documents. We have a bunch of different formats: PDF, Word documents, CSV files. So all of that can be ingested into the knowledge base. I'm going to talk a little bit more about that specifically. But yeah, we have lots of different ways that you can put together the knowledge base. And you can also even just use the application itself to house the information. Sometimes, even in the case of Parker, the information isn't necessarily well organized internally. Not to criticize, but that's just the way things are, right? As we have things that are kind of spread out, it might even just be in like a PowerPoint presentation or so sometimes we have people who are actually just copying and pasting information into the web application and using it to store the content there. So you can have a hybrid, and then you can also connect via API. So if you do have a robust outside data repository of information, you can connect that way. So for Parker, they do have an API connection to near real-time data about the position, temperature. I don't know, there's some sort of live data feed about Parker where you can ask those questions, and that's pulling from the API. This is an example specific to geospatial. This was one of the first pilot projects that we did with NASA, and we actually deployed this on their ArcGIS online portal. And so their issue is that they get asked a lot of questions even just about how to use the portal itself. A lot of the questions weren't necessarily about data, but there were more procedural type things. So being able to help people get to that more quickly. Now this isn't public facing. This was sort of a test case. All right, I gotta speed up. I thought I had half an hour.
We've been doing like 20 minutes talk, or if you need like 25.
Okay,
You have time.
I'm halfway through. All right, I'll speed it. Moving on. So I want to talk a little bit about the XR side and then also how these things come together. So for a long time, we've been working with virtual and augmented reality technologies and the underlying game engine to use them as a way to really push the envelope of what's possible in terms of geospatial and Earth observation data visualization. So we've done a lot of work with NASA, connecting to that portal, but also different projects, especially looking at disasters. So I want to highlight one of those projects for you because, again, this was an international multidisciplinary project. These were some of the project partners with the United Nations Disaster Risk Office, some local organizations in Central America, and working with the Guatemala city government. They had a multi-hazard risk analysis done for the city, and it was an incredibly dense document. It had a lot of information about the risks that Guatemala City faces. They have volcanoes, they have tropical cyclones, they have earthquakes. And so, they knew there was critical information in the document. The, city planners and emergency managers are kind of scratching their heads and saying, we don't know how to translate this information into something that's actionable. Lots of maps, this had seismic information, going back 1,500 years. But again, how do you take this information from the scientific data analysis point of view and then translate it into something that is actually usable? So what we did is we put it into the Unity game engine. And so you can really see this coming to life now. The information from that report had a lot of critical data around seismic activity specifically, and they knew that the last major earthquake in Guatemala City was in 1976. So that was one focus area. We also had lots of different data layers that you could turn on and off to be able to see other types of risk. And then they had actually 3D buildings. It turned out they had some of those assets. They were using them for property taxation purposes and not for city planning and emergency planning. So that was really cool as well to see how this project brought together different groups from across the government that weren't necessarily communicating with each other and giving them, again, that sort of common reference point of, wow, now we can bring this in. We have situational awareness. We can see local landmarks that are easily recognizable and then see the data overlaid to give us a much better understanding of what the true risk is for our city. This was actually used as part of a simulation drill that took place. This was down in Guatemala City in February 2022, and you can see it in their emergency operations center. We also sent 360 video out to people's cell phones so that they could have that sort of immersive view where they can pan around and be able to see what is the existing city look like, and then also where is the simulated earthquake. So for the mayor, for the visiting dignitaries, for the United Nations, this was really popular and exciting to them to get a much better sense of what is and what are we simulating, and so that they could participate in the activities more effectively. I want to tell you a little bit about wildfires because this is also a current focus area for us, and using all of the cinematography and effects that the game engine gives you, but using them with real data. So instead of just, using these effects to show a campfire or something, we are actually able to use it to create information about wildfires. And the point of that really is to, again, try to make things more understandable. There's a real gap between the research community and the end user community. And we see this time and again, is that the information might be out there, the models might be out there, they're not necessarily being used in the decision-making processes. So we want to be able to connect the dots. We did a case study for the Hermit's Peak fire that took place in New Mexico. And, this, again, just trying to illustrate how different types of information from disparate sources can come together into that common framework. So this is red flag warnings for the day that a prescribed fire was set in New Mexico. This is kind of showing you what 3D visualization typically looks like that we might see. And then, of course, we also have Earth observation imagery, and oftentimes these are totally separate. But with the game engine, we can actually bring them together. Now, I also want to bring the conversational AI piece into this as well and kind of show you again, this is future vision of how we think this could become a system that is really useful for understanding this type of information. After the fact, the Forest Service did a big after action report about this fire. Again, it was a prescribed burn that got out of hand and became a wildfire, burned for many months. It was the largest fire in New Mexico history. So we took that after action report and we put it into our Voice Atlas product and put it into the knowledge base, as well as information about the visualization and about the data sets. We're pulling information from a lot of different places. So for open science, this is really critical to be able to say, this is where we're getting it from, and here's a link. Here's where you can find it for yourself. That's not something that's traditionally done with visualization. It's much more, here's a visualization, look at it, believe me, this is what happened. This kind of flips that around and says, look at it, and this is interactive, and you can see for yourself where we're pulling the information from. So this is an example on the back end, just kind of showing the different types of questions that you can ask. And really critically, I think this is like, there's one takeaway, it's this: putting that report, which is an 85-page PDF document, into here now allows you to ask critical questions like, what were the lessons learned? How can we avoid this from happening again? This type of information is lost in so many reports. Think how many things are just sitting on a file server somewhere. This one is publicly available, but how many people have read it? How many people are going to retain that information and use it in a decision down the road? So I want to show you how this all comes together. This is a recreation of the Hermit's Peak fire. Again, entirely data-driven. You'll see that we also have information in there about the response. This was pointed out to us from some actual, firefighters and people who have more experience on the ground. And they said the science community never includes the response. And so they look at fire behavior, but they don't necessarily also look at it in the context of what we were doing to contain it. And so it's really important to bring together this multidisciplinary information to tell the story of what happened and to also learn how we can mitigate these types of things in the future. Now you can see we also have the conversational AI piece running alongside it. And so we are envisioning this as a truly groundbreaking way to change the way that we look at information and be able to interact with it and ask questions about, what am I looking at? Where did the data come from? What are the critical takeaways that I need to know? And again, it's only coming from that knowledge source that we've given it. I don't have a ton of time, so I'm going to try and just go through these videos really more quickly. So this is just, again, kind of showing you all of the examples for this particular fire. Future next steps, we're hoping to get a follow-on grant to now bring in actual modeled information from the Forest Service. They have models around 3D fuels and all kinds of things that would be very, very interesting to bring in and not just recreate a fire that happened, but actually look at potential for fire risk in particular communities and how something might occur, but also if we take mitigating steps, how we might avoid the worst catastrophes. This is a little throw out to OGC. I had put together a little knowledge base for one of the OGC members. And so this is just showing how you can quickly pull together a knowledge base and then start asking questions from it. So this is asking particularly about OGC standards that were used in one of their pilot projects. So the end results of this, hopefully that you'll get your real gears thinking about how this might be useful in the future, is that it has multiple uses within an organization. It brings together information from many different places. It allows you to really address some of these open science and inclusivity goals in a tangible way by making information more accessible, but also safe and secure and coming from those trusted sources. And hopefully with the visualization piece, also laying the groundwork for decision-making tools for the future. That's me.
Time for a few questions. If the next speaker wants to come up and start getting to then I'll go a little bit extra time for questions as well.
You have a question?
So